So first of all, I'm Justin Grammens here. Let me move this out of the way. A couple things, I guess. If you haven't met before, I'm Justin Grammens. I'm one of the co-founders here at Applied AI. We did a Let's Learn LangChain thing a couple weeks ago or so, and we didn't really even get through all of the material. And so I've got a lot of stuff that I really want to try and cover, and I actually see this sort of going probably for a couple more weeks as well. If you didn't attend last time, no problem. It's fine. I'm going to talk just briefly with regards to the stuff that we've covered in the first section, or the first installment. And I'm guessing everyone can see me and hear me just fine. Give me a thumbs up. Nam, I see you there. Okay, cool. Yep. So yeah, so if you're coming back, welcome. If this is your first time, no worries. We'll be able to get you up to speed pretty quickly. There's a couple things that I wanted to say, I guess. If you are not aware, we have the Applied AI conference is coming up on May 10th. And so you can check that out at appliedaiconf.com. And of course, all of our meetups, right? So if you attended this, you probably are already aware of appliedai.mn, but check that out. And I'm also looking for other people to potentially do other workshop Wednesdays. The whole idea around a workshop Wednesday is like, hey, let's take some time on Wednesday between noon and 1. Talk about whatever subject you want to talk about. So I've been working a lot in LangChain here for many months. I've done a number of different presentations on it, and I kind of wanted to sort of lead by example, I guess, show how we're doing it here. But if there's other things that people want to share over lunch hour, contact me, and we can set something up. So real brief intro about myself. Again, I mentioned, I'm one of the co-founders of Applied AI. I also have two businesses. One's called Recursive Awesome, where we do AI consulting and software development. And then also Lab 651, we have a whole team here that basically works on custom software development. I built an AI-powered online presentation coaching platform, actually to help people become better presenters. We actually have a weekly publication as part of Applied AI. I do a podcast as well. I saw Jim was on here. Actually, Jim, your podcast will be coming out next Tuesday. So excited to launch that. But if people want to be on the podcast, please reach out to me. I love having conversations, and those get released every 2 weeks, and it's podcast.appliedai.mn. And then I teach at St. Thomas and do all sorts of other stuff. So we talked a little bit about LLMs, kind of what they're good at, right? And this is some of the things that, of course, we know about generative AI. Where they fall down is, updated information, right? I mean, that's one of the core things that you probably are hearing a lot is they don't know about current news. And they also don't know about maybe your specific contents, your specific information, which is what we're going to address today. But LangChain solves a lot of problems around this. That's just one sort of piece of it. But these are some of the things just as a recap that they're not really good at right now. But the whole purpose of LangChain is to kind of be this orchestrator. And I'll slide down here to the next screen to really sort of give you a feel of sort of the components of it. And we went through the user and the prompts and the models last time. The really cool thing about LangChain is that you can kind of plug in any model that you want here. And we'll be using OpenAI, but you can use Gemini, you can use DALL-E, you can use your own local large language model, maybe that you would pull down from Hugging Face, which in a follow-up session, I'm just kind of thinking about what we'll want to do next time. I really think people will be interested in kind of seeing how we can actually use our own language models, but or some of the open source ones. But today we'll talk about OpenAI. We'll be using OpenAI, and you can inject memory, and you sort of have this chain going on, and that's what we talked about last time. And as I maybe mentioned, over in the comments is a link to all of the GitHub, like the entire GitHub repository. And in fact, I don't know if people can see it right now already, or if the comments are still there, but basically it's my GitHub /Justin Grammens /Let's Learn LangChain. And everything that we're going to go over today is all contained in here. We covered this one and this one last time, so we're going to go over sort of 5 and 6 right now, and we'll also talk a little bit about a really cool hosting platform for your Python notebooks called Streamlit. I'll kind of show you how easy that is to do. But we talked through this last time. Today, we're going to talk about agents and tools. So I'm going to kind of continue to kind of roll through this pretty quickly. This whole PDF is in the repository, so feel free to download it. You can read all the stuff that we talked about last time. And we talked about these various chains. The thing that's really interesting we're going to talk about today is these agents and tools area. And the whole idea of agents and tools is the idea that you maybe don't have all of the information, right? The LLM doesn't know what the current age of the president is divided by 2, for example, right? So what it can basically do is you can create an agent and you can say, okay, agent, here's a series of tools that you have to maybe answer the question. So you can say, go ahead and search. You can say, maybe look up on Wikipedia, maybe use a calculator, do some calculations of it. And there are just a billion tools out there right now. If you just Google LangChain tools, you'll find literally hundreds of them there. A lot of companies are trying to kind of course use their service, and allow you to sort of plug LangChain into it. So Twilio, for example, right? If you want to do SMS messaging right out of a large language model, Twilio has a tool that can do that. We'll be using the SERP API, which you're not familiar with that. It's basically, it allows you to run Google searches. And then you get back JSON, and then it can go ahead and parse it. So we can quite literally just automate the entire process of Googling for things. And then there's just a bunch of other ones. We can do stuff on YouTube, which I'll be showing you later. You can even start to query your own file system, which is pretty cool. I'll show you an example of that. So all sorts of these other things that you can use as a tool. And that's the first thing that we'll end up sort of jumping into. I'll show you how to create an agent, and then I'll show you basically how we can give it tools, right? So let's see some examples. So I'm going to hop over here right now to our Jupyter notebook here. And so here's the first two that we talked about last time. Again, kind of went over some of the basics and went through about how you create your own functions. Feel free to go back and read those and pull down the source code, play around with it. We're going to start here talking about agents. So as I touched on a little bit, agents basically allow you to load things and essentially make queries. And we'll see. I might have to backtrack a little bit, maybe bring people up to speed with regards to how that works within LangChain. But this is how simple it is to start interfacing with a large language model. We go ahead and run this. We're going to use some libraries that are out of the agents directories. You can see here I've installed a number of different other ones as well, just using the pip install. And then you can create OpenAI. You could use Gemini. Like I said, you could create whatever you want. But this is the beauty of what's going on with LangChain is you can swap out different models like literally with one line of code, right? So here we create. I'll go ahead and just run this here. This shouldn't have any problems running. I'll go ahead and just sort of step through this cell by cell. We've created a LLM variable. And people have maybe heard about retrieval augmented generation, right? This idea that you can actually augment the large language model by actually going out and retrieving information. And so this is a use case that we're going to kind of talk about, right? So how does the large language model know who is the president, right? How would the large language model be able to actually use your own data, which we'll talk about in the next one? How can you extract information out of a PDF and have it be able to use that? That's the whole concept around RAG, right? It references authoritative knowledge, based outside of its initial training set, right? So in this case, we know that we are going to want to be able to do a search. We're basically going to create a series of tools. Now, the other thing that's really cool, and I'll show this probably in the next week, is that you can build your own tools, right? You can literally have your own tools do whatever you want to have it do. We're going to use the SERP API and the LLM math ones. Like I said, if you were to use Twilio, you just drop Twilio in there. It's basically tools that are available to anybody. And then what you can do is ask this tool, like, what's the description all about, right? And so then, I'm asking the first tool, right? So it's a search engine useful for when you need to answer questions about current events. Inputs should be a search query. Now, you may say, okay, Justin, that's fine. Okay, cool, there's a description, whatever. Well, that description is actually very important because when a large language model gets a request from you about things, this is what it goes off of. As it'll look through its tool belt, right? Its tool set here, and then say, oh, okay, if there's something around current events or something that I need to search on, this is the right tool that I want to use, right? And so you as the developer in this case, you don't need to write this description. And I'm going to show you basically what happens even under the covers with regards to sort of doing prompting We talked about it last time, the idea of actually creating a prompt template. Each one of these tools creates its own prompt template. So it basically says, okay, large language model, here's all the tools that you have. If you have something that you might want to use this particular tool. In this case, the large language model is smart enough to use it. And then it's actually smart enough to then say, okay, use this prompt, right? So what I'm doing here is initializing all of our agents. I do want to talk a little bit about this concept of React, and it's not the React that maybe a web developer might know about. It's this idea of reasoning and action. And if you Google for React and chain of thought with large language models, what we have found is typically large language models are not good if they haven't seen if they haven't seen very, very many examples, right? So if you have a specific use case that you want to deal with, you can sort of add what's called one-shot or few-shot prompting, where you can basically say, okay, in this particular case, here's the answer, right? And so this idea of, if you can see this, standard prompting it's fascinating, really, how these large language models, if you show them how you got to the answer, then when you ask them another question, they follow that same sort of logic, that same sort of thinking, that same sort of chain of thought. So the more you can do this ahead of time, and this is what people talk about prompt engineering, right? If you can sort of coax the model and give it enough examples ahead of time, it's going to be very, very good at answering questions that it hasn't seen before, or similar questions, right? If you don't, and you just expect it to sort of figure it out along the way, this is where you start having, error propagation and hallucinations happening. Not to say you won't get the hallucinations or all the other stuff, but the more information you can give it up front about how to get to the answer, the better. So what's happening in this case here is we have a tool, and what we're trying to do is tell the large language model, okay, use it in this particular case, right? If there's a current event or there's something you don't know about, cool. And then what I'm going to show you is basically the underlying prompt that whoever built this tool, and when you build your own tool, you'll write your own as well. But all of these tools basically have their own template. And this template is what ends up getting passed to the large language model, and it really sort of pre-feeds it with regards to how it's going to figure out and find the answer. So in this particular case, it's interesting. You say, okay, I'm basically saying Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each has 3. How many balls does he have? He has 11. And then you ask it the same or a very similar question. Cafeteria 23 apples. They used 20 to make and bought 6 more. How many apples do they have? It actually gets it wrong. And why does it get it wrong? Because it didn't actually understand what the heck it did in the first case to get to the answer. And if you can give it a question and then explain to it how it got its answer, or how it should get its answer, and this even works too. You might say, explain to me how you got your answer, right? And you'll actually see the large language model actually improve in that. But in this particular case, you sort of tell it, okay, Roger started with 5, 2 and 2 has 3, each has 6, right? The answer is 11. And then when you ask the harder question or a different type question, it actually knows, based on the prior context, how to figure it out. Does it? So it goes through this chain of thought, right? And that's basically leading me all the way back to this React idea, this whole idea that you're basically going to have reasoning and then actions that are going to happen out of those. So this is a very simple diagram here where we have a question, it'll hit some thought, it'll hit some action, have some observation, it'll kind of go around and around here, and then finally end up getting the action. And you'll see this in action when we start asking some chain of thought questions of it. And so I showed you prior, we asked basically the agent, tell me what the description is of the tool, right? So it talked about search. We also had another one that would have talked about calculations as well. And so here in this particular case, I've loaded it up with multiple, we have our entire chain. I've loaded it up with our tools that are here. And if I go ahead and run this, this is the template, the prompt template that will get passed to the large language model, right? And again, you as the developer, you don't have to write this template, right? These people wrote this template for each of their tools. And then LangChain, the beauty of LangChain is it just allows you to load these tools in, and it writes all of the contextual information, I guess, all of the templates and the variables underneath the covers. So what the large language model sees is answer the following questions as best you can. You have access to the following tools, right? Here's search, and here's our search engine, right? A search engine user would need to answer questions about current events, right? So this is what gets passed in. Input should be a search query. So grab the description, drop that in there. I didn't show you what the calculator one looked like, but we're going to do some calculations. So it's going to be smart enough to say useful when you need to answer questions about math. And then use the following format. Question, the input must be an answer. And then look at this, it says thought. You should always think about what to do. So it's guiding it through this, and you'll see there'll be an action and an observation, and how does it know how to do that? It knows how to do that because it's using natural language and using prompting, a prompt template, to talk to the large language model under the covers, right? And so that's what's really cool about this stuff is other people have done this work, and you can, in effect, stand on the shoulders of giants who have written these templates, right? And you can override them and stuff like that if you want. But out of the box, they work pretty well, right? So we have actions that happen, and it says this, thought, action, observations can repeat n times. Here's our thought, and here it says, now I know the final answer, and once it hits the final answer, then it gives you the response. Now you'll see at the end here, here's input. This is it's a variable called input. So whatever you end up passing into the large language model, this is what it ends up showing up here. But this is how your stuff gets passed in and used. See something in the chat here real quick. Popped up. Understand prompt engineers are all independent, so it may not be the best. Cool. And please feel free to unmute yourself here at the end. I think we'll have like some time here, a good 10 minutes or so at the end for us to ask questions around certain stuff. But in the meantime, feel free to follow along. So we've got our template here. This is all the stuff. Hopefully that makes sense. You're sort of seeing this sort of actions happening under the covers. And I'm going to go ahead and just run. Hey, hi, how are you today? And I ran this in the past here. See if this is the other thing that's kind of interesting. Is sometimes you'll actually end up getting questions that if it doesn't have, of course, it doesn't have the tool, right? I can answer this question. It's not a factual question. So it's realizing that, okay, the tools that I have there, I don't really know how to respond to this question, right? And that you can play around with the temperature settings. And, if I ran it a second time, now it says I'm doing well. Thank you for asking, right? So it'll fall back to whatever the regular large language model output would be if it doesn't actually know what to do. But if we go ahead and run this, say who's the current president of the United States, I'll go ahead and run this. Let's see what happens. So it says, okay, I should search for this information. And I have the debug turned on so you can sort of watch this sort of go through. It says I should search for this information. The action, remember, so it's going to kind of go through this action, thought, action input, round and round until it finally finds the final answer. It says current president of the United States, observation is Joe Biden. So in the model, that is the answer. However, it says I should double check to make sure this is correct. Remember our template said you should always check your information, right? So it calls up the search tool, and basically ends up running a search. And it actually now, interestingly enough, so this is what's kind of fun. Like every time I run this, it actually behaves slightly different, right? So that it actually ended up getting stuff that you're not back from Google that was not actually useful, right? So it said I should try a different search query. So it actually asked the question now. Instead of just throwing Joe Biden into Google, it actually says, who is the president of the United States? So it learned that actually didn't get the right answer back that it wanted, ran that question, actually ended up getting Joe Biden, says this is the correct information, and then that's when we hit that final answer, right? You're always going to see that at the end of these examples. It's like, okay, I've done my little experiment. I've looped around a couple times inside of this thing. I've sort of followed this reasoning idea, and now I have the final answer. So pretty cool, right? So using these tools now, on top of a large language model, you can ask it questions, and it can actually go out and query the internet and bring in real-time information and sort of feed that back to you, all in a natural language, response, right? All sounding very, very human-like, which is fabulous. I'm going to run the next one. What is the average age in the United States? You see what I ran it before. I'll go ahead and run it here too. So this one's interesting, and we'll see how this ends up playing out. Because like I say, every time you sort of like try this, it's kind of trying a couple different things. Here we go. Cool. So it's smart enough to say, oh, I should use a calculator to find the average, right? And remember, the template that we had and all of the tools at its disposal said use this for calculations, right? So it says average age in the United States. I don't know how it got 68.5, right? But it did. And so based on the information that it had within its model, it thinks that it's 68.5. Now, I probably could have prompted this a little bit better, right? I probably could have fed it some information ahead of time, but I'm being very generic here on purpose to sort of see, well, what does it do, right? And again, it hits that same sort of thing. Oh, well, I should double check this information with the search. And again, I haven't had to do anything here as a developer. I've just basically set up the tools that are available at your disposal, go ahead and run this and get the responses. And so it actually ends up running a search. Average age in the United States gets a whole bunch of stuff back in here. Somewhere buried in here is an answer. And the answer is 38.5. So the average age in the United States is 38.5. It ends up getting back that answer. And it actually, you know, what's cool is that it didn't just throw back 38.5, right? It actually responded in a human-like manner, right? The average age in the United States is 38.5. That's what's so cool about this stuff is like, you know, it's actually using natural language to do the queries, to get the responses, to think about what it needs to do next, and then to actually respond back to you in a natural language. This is another simple example here as well. I'll load up this tool. This is you know, allows us to use the search API, allows us to use math. I've added two more here. One's called Wikipedia, and then the other one is Terminal, which I told you can actually start doing stuff on your local machine. And so I loaded up our agent variable here. The only thing I was showing here is like, you know, review the templates for this. So you see we have search, we see we have calculator, but you'll also see we have Wikipedia now, right? A wraparound Wikipedia, useful when you need to answer general questions about people, places, companies, facts, historical events, and other subjects. So that is in the prompt template that is being sent to the large language model as things that it can use. There's also terminal here, run shell commands on this Mac OS machine. You must know I run Mac, right? Interestingly enough. And so then, yeah, so after that stuff it goes through the same sort of question, response, action sort of, you know, follow through. So if I say, where is Apple's office headquarters? In this case, I'll roll back to here. It says, oh, I should use Wikipedia to find the information about Apple's headquarters. Goes ahead and makes a search here, has an observation, actually ends up looking through a couple pages, which is really cool, actually. I mean, you can, if you wanted to, you could just put Wikipedia on, not have all the other tools there. And then you can just query for anything you want. You know, you can let it do the hard work of parsing through various pages on Wikipedia and finding the answer, right? So here it found a summary and stitched it all together, right? Final answer, Apple's office headquarters is located at Apple Park in Cupertino, California, right? So I ended up getting that as an answer. The other new one that I think I talked about was terminal, right? So let me run this, say, what are the files in my current directory? And this basically, what it does is just runs an ls command, right? It's smart enough to basically say, okay, I'm going to take a look. I'm going to use the terminal tool. I'll do an ls on that and lists off everything that's there. I now know the final answer. Here's all the files that are in your current directory. Let's see if we can tell me how many Python notebooks I have in my directory, right? So this is another fun thing, right? So I haven't told it to do star.ipynb, right? Which is basically what the extension is for Python notebooks. I've just said, tell me how many are in my directory, right? And then count them up, right? So this is what it does. It runs code locally on your machine, which I tell people, don't tell it to remove things because it's going to run it and remove it. So you got to be careful on what you're asking for, but it actually ends up running this command. In fact, I think there's I want to say there was a user warning. Yeah, the shell has no safeguards by default, right? So be careful with that one. But so it ends up finding the ones that are there, and then it says, let me use a calculator here, right? And these are one of these cases where people are like, yeah, large language models they're terrible at math. Yes, they are terrible at math. And so what you basically need to do is a lot of these tools actually end up running code locally on a machine that is very much more deterministic. It knows the answer and it will actually call the Python library to add up the number of files that are there. So really cool, really cool example. So that is sort of my overview here on these LangChain agents, right? This whole idea that you can actually have agents that can work on behalf of you, let me see, yeah, that can basically work for you, and based on your question, they're prompted under the covers, right? The large language model is prompted under the covers to say, here's the tools that you should use for these particular things, and then here's the template that gets fed. So you're more likely, that's what I guess is what I should say, you're more likely to actually get the right response than if you were to try and write all of this yourself, right? If you imagine all the work you need to do to basically, not to say that this is hard or very super complex stuff, but the whole beauty of what I want to show you and emphasize with LangChain is all the work's been done for you. And you can just chain these things together and stitch together the responses, and you can, like I said, you can create fully functional chatbots, fully functional agents, and or fully functional apps, I guess what I should say, on top of these agents. It's a really, really super powerful platform. So, so that's the little agents piece, right? If we go back and, looking back at our picture that we had here, here's our agents and our tools. So the other thing that I want to talk a little bit about, if you aren't familiar with, is just this idea of vector databases, right? And how you could actually create your own little vector store. So you have a whole bunch of documents internally that you want to have the large language model learn about, and only really learn about that, right? And so people have been talking about embeddings and vector databases. I want to, kind of, I guess, go over that real quickly here with regards to how that works, right? So embeddings are just numerical representations that are converted into number sequences. And so, a particular set of words, feline friends say, it goes through this embedding model, and then you actually end up getting a long array, 50 some, values that basically tell, that have a representation of where this would live in vector space, right? And so us as humans, we can probably picture three-dimensional space, but once you start getting out into 50 dimensions, it's very, very hard for us to pick it up. However, computers are really good at that, right? And so you can throw words and actually end up getting back all of your text as a numerical representation, as a vector. And OpenAI actually provides a embedding service. You can throw text into it, and it will give you back all of the vector values. And you need to chunk it up along the way, but it will give you back all of the vectors for all of the words that are in your database, or that are in your document that you feed to it. So we're going to leverage OpenAI to have us basically do a conversion, right, from words into vectors. And then we're going to store those vector values locally inside of a local database called Chroma. And again, just to be clear, out on GitHub, you can pull this down and run this all on your own. But what I wanted to emphasize here was, once these embeddings happen and you get the vector values for them, you start getting these clustering, right? This clustering impact where, felines and woofs and meows, canines, all that stuff sort of lives up here, right? And so computers and essentially the large language model then will start to understand the relationship, and we can leverage the relationship between these words and the concepts, and realize that using similarity searches, we can basically say, okay, things live up here, they're all related to each other, and then a quarterback throws a football is totally across the other side of the world. But what then can allow us to do is we can actually generate queries. And again, this is going to be stored, all these vector values are going to be stored inside of a vector database. You can have a query that happens. You can search across your documents for those values and have it be basically passed into the LLM context window, and then get back an answer. So this is how we can store documents in a way that you can easily then use a large language model to query against it, right? And so I'm going to show you an example here inside the GitHub repository. I have a constitution.pdf, which is literally just a PDF of the Constitution of the United States. And what we're going to do here in this chunk of code here is we're going to instantiate Chroma. As I mentioned, there's probably 100 different, probably more than that, vector databases out there. Chroma is open source. It's free. You can run it just in memory, or you can actually have it be persistent if you want. Here's where I talked about our OpenAI embeddings as well, but I'll kind of walk through this sort of line by line here. But this allows us to use a PDF loader, which basically is part of LangChain. They have a whole bunch of document loaders. If you want to load a Word document, image, whatever it is, we can create a loader object or a loader variable, and then create our documents. And then I'll kind of gloss over some of this stuff, but it allows us to then basically chunk up. We use this character text loader to set various chunk sizes. And I'm just kind of using the default ones here, but but figure out how many characters per chunk to overlap. And it's sort of a play, a little bit of a game with regards to, how small the chunks are and like, but this document's not very, very big, but I just sort of use this out of just some of the default values that everybody else uses, and we go ahead and split up the text. I talked a little bit about OpenAI embeddings, right? So they actually have a service that you can go ahead and pass stuff through. So we can take our embeddings and then for each chunk, insert it into the Chroma vector database. And so under the covers, basically, as you're making this call, this text, all of this text information is being fed into the database. Then, which is, again, all of the vector values. Then we can create our large language model. And then the final thing that we do is we can say, okay, basically use this retrieval QA, which allows us to essentially use a question and answer type input, right? So we have a LLM, we have the retriever that we want to use, which is our database. It's basically saying, okay, just use the database to retrieve all the information. And then we have a chain type. There's a couple different chain types that are out there. I haven't delved into all the various versions of it and what stuff means, but it seems like stuff is kind of what most people use for just these generic documents. I guess the other thing that I would say here too is LangChain is still pretty early. I mean, I think their first, and you can look back in some of the initial slides, but I think they just launched basically their first version, public, version, and I don't even think it's 1.0. It's like 0.10, just like a couple months ago or so. So a lot of this stuff has been in flux. They have just raised a large financing round, actually, and they're hiring team, actually, which is pretty cool. And so a lot of this stuff is really getting tightened up. But I will say their documentation is really good. There's a lot of stuff out there, a lot of YouTube videos, a lot of examples that people are sort of showing what's going on. So, to me, it's sort of like the default, but you'll find little stuff like this, like, well, what does stuff mean? You can go back out and sort of like dig into it. So, but in this set of code here, what we're doing right now is we're loading our Constitution PDF. We're going to go ahead and vectorize all of the values that are in there and store them in our database. So cross my fingers, I'll go ahead and push it and basically run it here. Right now, it's loading it in. Mind you, it's actually generating all of the stuff and loading it into the database. So, it's not something that just happens instantaneously. So it took it about 9 seconds. And then, so the chain is all set. Let's start asking it some questions. So we can say, what is the age required to be president? If you go ahead and ask that question, inside the document, inside somewhere in there, it tells you what the age is, right? So what we've done here is essentially summarization, right? We have a document that we've loaded in. We have the large language model that knows about all of that information. And we can ask it questions around, what's the title of the document? And again, it's just inferring, right? It's figuring that out. It saw that the title page is the Constitution of the United States, and it's able to figure all that stuff out. Can ask it maybe who signed this document, signed by the delegates, conventional, some of the notable signatures include right? So pretty cool stuff, right? It's basically taking a document, and again, I'm keeping it pretty simple here, but it's taking a PDF that maybe you have, and then allowing us to then ask questions and queries about it. I'm going to ask it a question, though, that's outside of the current scope, right? I'll basically say, like, what is the size of the moon? Notice that it doesn't actually know the answer to that, right? So this is a really good example that shows, the model's not wandering off, right? It's not looking for something else that it had found on the internet. It's very, very tuned into specifically the document that you gave it, and it uses that to retrieve all of the questions that are there. So cool. Hopefully people have found value in that. Somebody else had a chat question, open source embeddings. Yeah, so Hugging Face, there's lots of different ways. And note here too, yeah, you want to use the same. Not that they, again, I think each of them probably has their own quirks to it. And there probably is no one source of truth, and everyone's sort of one-upping each other with regards to how they create these vector databases. So absolutely, for sure. You want the same stuff to go in, the same algorithm that figured out what to go in, basically use it on the way out. We're at around 12:35. The second part of today here is going to be about how can we get this on the internet, right? How can we, it's just cool, Justin, that you can show me how to run stuff on a Python notebook, but like, what if I want to stand up my own little server, right? And I want somebody else in my company to come in, and maybe I want them to basically be able to upload a PDF, for example, right? Or I want them to be able to ask questions of a chatbot. How can you do that? There's lots of tools out there to do this, obviously, and there's a whole different range of skill sets and everything like that that might be needed. But if you're not aware of Streamlit, you definitely need to check this out. Um, I think it's really powerful in that I'm not a front-end developer. You know, I came from software engineering. I've been doing software engineering for, you know, more than 20 years or so here. And when I got into this stuff, you know, many years ago, I was kind of like of that same opinion that I had before. I was like, wow, this is cool. I can play around with the Python notebook, but like, I actually want to get this thing on the internet, right? I want to have a web interface on top of this thing, right? To me, it's useless, frankly, just sitting here writing Python code and running like notebooks manually in the background. It's great, and again, I'll step back from that a little bit. It's great to experiment. It's great to experiment and play around with, but when you want to actually build something that people can interface with or build an API on top of, this is one possible way to do it, right? I guess the other thing that I will mention for people that weren't here last time is actually LangChain actually has a thing called LangServe, which is really cool. It's very lightweight server that can spin up, and will basically, you can create endpoints very easily for people to ask questions into. So LangServe is a really good. It's just kind of a companion tool that comes along with the entire sort of LangChain ecosystem. And so Streamlit, you know, I'm just basically gonna run this little example here. So imagine you have a Python file, right? And all we got to do is basically say import Streamlit as st. We can basically say st.write, my first app, and ta-da, you have HTML on the front end, right? It actually builds you a little HTML front end for that. Then you can say, you know, I actually want to create a window. And I want to create sliders, right? There's just tons of different widgets that you can start adding and building into. And mind you, you're driving all of this just with Python code, right? You don't need to understand HTML, CSS, any of that stuff. So, and then allows you to kind of deploy it, right? So what I'm going to show you is a Python file that looks very similar to the Python notebook that you just saw, the Jupyter notebook that you just saw. But then we'll run it in the browser, right? So the goal here is to create a little interface where we can upload the Constitution and then maybe ask those same questions about it and sort of see what happens. So the code is in the repository. There's a thing called LangChain Chroma test. And again, it's just basically, since we're using Chroma under the covers, but what we're building here is you interface, again, all of this text here, you're going to see a little text box. It's going to say, enter your query. You're going to see a button, basically says, ask question. And then when somebody clicks the button, you're going to see a spinner that's going to happen. And then what's going to happen in here is a lot of the same stuff you saw before, right? We're going to use the PyPDF loader. We're going to go ahead and create a temporary file here. We're going to call our open AI embeddings. We're going to load up the vector database. I mean, all that exact same stuff really happens here underneath the covers. But what we've done now, if I go ahead and run this, is you'll see a web interface that'll be built on top of that. So let me go out here, go ahead and say Streamlit run. You should see a new tab just automatically launch, basically did it for me. And it built this little interface for me, right? And I didn't have to do anything other than just take my script, wrap it around just a couple of, ST Streamlit objects, and ta-da, I basically have a thing that's here. So let's do the same thing that we did before. Let's ask what is the current age to be the president of the United States? So if I click browse files, I'll go ahead and grab my Constitution here, and I'll say what age to be the president of the United States. And what should happen underneath the covers here is it should load the PDF, should go through all the same stuff that we had before, and it should actually end up spitting back the question. But the beauty of it now is that now you can serve this up to anybody, right? Anybody within your company or anybody else, right? So ta-da, that's what happened. It basically parsed the PDF that was there and did all this same stuff. So I just wanted to show you sort of the value that Streamlit can bring. And it doesn't need to use LangChain. I'm kind of fascinated because it's kind of cool, because now we can like essentially put a nice UI on top of LangChain. So you can use it for anything you want. So I'm just a huge fan of Streamlit. I did want to talk real quick too as well about another Streamlit one that I was trying around, because I was sort of poking around at some other tools that we have out there. And there's actually a tool that you can use that's called YouTube Transcript. And let me just make sure that We talked about Streamlit. Yeah, actually, why don't I show this real quick? Probably got a little bit ahead of myself, but this is just a graphical representation of kind of everything I've said in the past 5 minutes, I guess. As a user, you're basically able to create a front end using Streamlit, and you're basically ends up allowing you to use the LLM frameworks that you have, call the OpenAI a large language model, and then have access to all of these things that we're talking about, right? And so in that first case, we didn't really have an agent, really. Yeah, I mean, other than the fact that we went out to OpenAI and pulled in all of their stuff, all of their embeddings, that we didn't really query the internet. We didn't really actually go out and pull anything else in remotely. But all those are available to you, right? If you actually want to do anything that was in the LangChain ecosystem, you can. And then those responses end up coming back. So, two distinct systems. I want to be clear with that. Some people think that they're like related, and they're really not. They're two separate projects. But it allows you to then actually open up the world of LangChain into any application that you have. So I'm going to show you a second one here that actually is a YouTube transcript chatbot. And so it allows us to, we'll basically use a YouTube loader tool. And you give it a URL, and whether, I'm not sure if you guys knew this or not, but YouTube has an API to allow you to essentially query and get back all of their transcripts for a particular YouTube value. So here we just load it. We do the same thing though, right? We're actually using embeddings, our OpenAI embeddings, and loading it all in. So instead of the source coming from a PDF file, it's actually going to come in real time off of the internet, off of a various YouTube channel. And so I'm just going to grab a YouTube one that's here, but this does the same thing. I'll talk about this in the next session around histories and how we can actually build on top of each other, but we're going to focus on this part here. And if I go back here, and let me kill that first one, I'll go back and run LangChain YouTube.py. You'll see the browser will pop up. It'll basically show me the interface that I had here, which was very simple. But again, I didn't have to write anything at all to do this. All that I needed to do was use my Python code. If I drop in this YouTube URL that I have here, and then ask it a question. I think I had a question here based on the transcript. What are you never going to do? If I do this, so it's going to be transcript downloaded in chunks successfully. It says based on transcript, you're never going to give up, let down, run around, deserted, make you cry, or tell a lie, hurt you. So if you take a look at what this example was, I think the YouTube that we had there was our friend Rick Astley. So you've all been Rickrolled this example, but it was actually able to take the whole transcript out of this video and get the response of what was there, right? So this could be any transcript, right? I had fun with you guys basically doing a music video, but it could be a 2-hour long boring lecture, right? It could be my presentation. It could be the thing that I post out here, right? You could basically use this to roll over all of my text that I talk about and then start asking it questions. What was the most important part that Justin talked about? Well, what are the key concepts that he tried to get across, right? So super powerful, right? I mean, this would be a pretty fun thing for you to be able to maybe show other people is that, hey, we can pull in content from anywhere. It doesn't actually have to be a PDF that we have. Or even something that's internal, we can pull it in from other sources, even public sources as well. So that kind of covers what I was going to talk about today. I think I showed this. As I said, the source code, if you wanted to scan that, you could do that. Otherwise, like I say, it's in the meetup that was sent out. And I did post it in the chat, like right away at the beginning. Yeah, okay, so people got the repo, all that type of stuff. Everyone's been rickrolled, perfect. Yeah, cool. I'm glad. Thanks for posting the source code link there. And I guess for right now, I'll open up to questions. I don't know. I've just been kind of rolling through this right now. We have a little bit of time. Hopefully this was useful to people. I'm more than happy to sort of tweak stuff if there's other things you think are interesting, but you either drop something in the chat or just unmute yourself.
Justin, this is Srinivas. Thank you very much for this presentation. This was great. Regarding the chain of thought, I mean, that was actually pretty good. I was just wondering from your personal experience, or maybe somebody from the audience can give us a different example that's more business related and how they found that chain of thought to solve the problem. I mean, I'm just talking about beyond using a calculator and the SERP API.
Hmm. Yeah, has anybody built anything else? I mean, I think I'm just sort of kind of going off script here, but I think if you look at the tools that are out there, there's like literally hundreds of them that are out there, and I feel like I feel like two pieces to this. Number one is I don't think you want to overload it with too many, too. I think if you were to feed it like 100 tools or 50 tools or whatever, it would start actually going down some wrong paths. So that's another thing I wanted to be clear about this is I don't think it's good. I think a lot of these agents that you build are going to want to be specific around certain things that they do. You know, the calculator example I showed was kind of, you know, interesting. Like, oh, okay, you know, it basically needs to go out and, you know, find a number or divide by it. But I would say that that is a tool that you're probably going to want to have pretty much across the board if you're doing at all anything with regards to mathematical operations, because I can see businesses. This is where the hallucinations come in. This is where people actually end up getting the wrong data, and then they kind of trash the large language model. They're like, "Well, that thing's terrible. I'm not going to use that." So, you know, I would say if you're at all in the financial industry and you at
Yeah.
all want these large language models to sum up data, that to me feels like a good tool and a good use case, but that's just kind of one I just thought about right now. But others, yeah, go ahead.
Yeah, different. So I have published, I have built and published 8 of the on ChatGPT Marketplace. Um, and I have used the value code in and also the text form. Um, and it was mostly focused on the specific areas of cloud, like cloud migration, system design, and cloud security, and you know, cloud advisor, and such things. It was revolving around 90 speed adoption stuff, and also the instances were especially on the cloud side.
Okay, yeah, we couldn't hear you very well on that, but hopefully we caught the gist of what you were talking about. If you had anything that you wanted to mention too, feel free to drop it in the chat, Aisha. If you have any
Sure, sure,
examples.
sure. Sorry about that. Let me do that. Let me drop it on the.
Sure. Yeah, again, I would just say if you just go out and take a look at the tools that are there, I think, and then apply them to your business case, right, as you come across it. I think, and that's a great question, Srinivas. I mean, I should come up with some more ideas of things that are using it. Just trying to think. Somebody had a question here about, you know, what did I spend on this demo? And it says, hopefully just cents. Yes. And in fact, if you haven't used the OpenAI API, I went in there and loaded it up with $10 like months ago. And I haven't even scratched the surface on this stuff. So yeah, we're talking, you know, tens of thousands of a penny for all the stuff that I did here today. So yeah, not really a whole lot. Thought I saw something here as well that I think Ralph, like how did I launch into Streamlit from VS Code? I mean, so the VS Code is just where I was coding the Python, and then I just basically went out to my terminal and then just ran it, right? So I just basically ran Streamlit run and then the name of the Python file. So wait, when you install Streamlit, so you do have to do a pip install of Streamlit. It ends up getting installed into your path. And then you say Streamlit run and then the Python file. The one thing that is kind of cool that I think is like you just give it the Python file and then it'll launch Chrome, it'll launch your browser, and it'll take you sort of like right into it. And there is even a mode too where I don't know if you guys saw, but you can have it auto refresh, auto reload. So as you're making changes to the Python file, you don't even need to go back and like refresh. You can just it will automatically sense the changes and make them. It's kind of cool. Brent, see a hand up.
Yes, first, my audio and video working all right for you folks?
Yep, I can hear you.
Okay, good. Yes, in the weeks between this and the last presentation, I played around with LangChain on my home computer and I'm having a blast. It was a hard-won knowledge. I attempted to get LangChain going and attempted to get the Visual Studio extension working, but ultimately had to fall back on just running Jupyter Notebook directly and using its web interface to access the LLMs, but was able to do so. I'm this like big open source guy, so I'm running running a Llama 2 locally for the LLM. It's I can ask it questions and made simple prompt templates and chain some things together with the Piper operator. Lots of fun times to be had. Is there like an easy, my question, an easy sort of example of how to do image generation or let's say non-text responses from the LLMs? I think you can just chain stuff together the way you do chat and search and so on, but I don't know practical examples.
Interesting.
In the Jupyter notebooks, it draw me a picture of a flower and then hit run, and then like I don't know how that would play out.
Yeah, I love, so these are all seeds and ideas in my head with regards to what I'm going to show next time, right? So, yeah, Hugging Face, outside of LangChain, you can just, go to Hugging Face and then actually use their ecosystem to basically pull down and run scripts, Python scripts that will just interface with the large language model directly. And so they have some pretty interesting open source text to image generators. They have sound classifiers, they have sound to text, they have text to sound. There's a whole bunch of stuff out there on Hugging Face. And again, you got to figure out, you got to sort of find the most popular models, for example, that are the ones that are going to get the results that you want. But the example that you showed, I think I just took a note of it because maybe that's what we'll actually use as our example. Because I was going to show a local run model. And if you look at any of the variables where we create our LLM object, I call OpenAI and I pass in temperature equals 0. That's all that I do. But I could literally, and maybe you know this already, but I could literally just path out to like, /user/Justin/the model, and I could load it in through that. So LangChain, it should totally work, right? Any model that you pull down and you run out of Hugging Face and you sort of use their, they basically have a, what's the term that they call it? Yeah, I'm sorry, I'm spacing on it right now, but there is an object that they use that allows you to load the model. And LangChain should work exactly the same way. So to answer your question, I haven't done it. But I know exactly how it would work, and we could definitely play around with that next time. I would be surprised if you get very good examples, if you get very good responses on that.
Justin, this is how I'm wondering if you have reference to Hugging Face transformer libraries. I think that's the one you're using. Either you can download locally or you can interacting with some others.
Yes, the transformer libraries. Yeah. Yeah, and so I haven't tried the image generation, but I know that they have ones that will do all sorts of different stuff. The image generation, as I'm sort of like talking through this right now in my head, they're basically using adversarial networks, right? The whole idea of these GANs kind of working against each other to generate these images is how we are getting such good images. And so I haven't done image generation locally on my machine, so it's gonna be fun. I definitely want to play around with it. Has anyone tried this? I'll open that up to the community. Has anyone tried using their own open source model to generate images?
I have tried this thing. So I have tried Ballet on ChatGPT and also like the Ballet is part of Microsoft Copilot design. So the way I see it is the first image has better accuracy compared to the second image for the same prompt and same input, but the accuracy keeps on decreasing. And the challenge is when it comes to following the prompt, it is not 100% accurate, and there are always spelling and the grammatical and typo errors.
Aisha, yeah, we can't really understand what you're saying, so maybe you could just put stuff in the chat. That would be great. Yeah, and so I speaking of the chat, I basically dropped in basically all the text to images. You can just click on that, and there's a whole bunch of text to images that are there. Somebody mentioned Stable Diffusion. Absolutely, I've played around with that, and that's actually really good. You can generate stuff locally. There's an entire system. There's just an entire package you can download and run it on your computer. You might hear the fan of it'll start to spin up, but Stable Diffusion works really, really well. So yeah, I should have thought about that. I haven't, but the sort of the beauty of Hugging Face is it'd be interesting with the LangChain idea, like, okay, generate me an image, and then based on that image, post it out on my blog. You know what I mean? Put it on my WordPress site. And by the way, based on the image that's generated, why don't you generate me a blog post, article, right? And then send a tweet out. So these are the types of things I'm talking about that you can stitch together using LangChain, right? And this is what makes it super powerful, is that we can automate, and we can use the best model for the best thing that we want to do, right? We might actually have a database that has a whole bunch of old tweets that we did that we want to actually have a query from, right? We can pull that stuff in real time. We can take a look at our Google Analytics and basically say which platforms are performing the best, which social media areas should I be going, what time of day, right? And so this is where my mind just gets blown, and hopefully everybody else sort of sees the power in us being able to use LangChain in those typical ways to create entire workflows, entire automation for us. So I wanna make sure we have enough time. Harold, do you have a question? And then I really got to drop it in about 2 minutes. So
not really a question, but I wanted to share some of the things doing at my company. Can't get into a lot of details, but we have probably more than 100 experiments going on, and several projects that are standing up with clear return on investment expected in the 500, 800% range. So most of them are knowledge-based groups, so specific knowledge sections within parts of the company, and they're going to bring them in as part of like RAG and then enhance the question answer with fine-tuning. There's basically some machine learning stuff equivalent going on. We're using, because they're heavily text-based, so instead of using the data we have, we're using the text associated with it, and then combining it with the data to get better answers. And then we're doing a lot of chain of event kind of thing. So basically running development of an application from the initial idea to requirements to project management steps to the tasks that need to be done to having something write the individual tasks and then somebody reviewing them and then implementing it.
Nice. Yeah, I mean, that's the power. I feel like it can be used in so many different areas across an entire project. And I'm actually speaking in a couple of weeks at the International Council of Systems Engineers conference, and I'm just going to be walking through, like, how do you go from ideation to completion, right, for a software development project? And it can literally be used from every role along the way, right? Every person, from the product owner, the product manager, to the systems architect, to the project manager, to the QA, to the documentation, to the support, right? There's really no area where you can't actually use this because it can be a great guide, and it can be a great I guess source of knowledge that you have at your fingertips at any time. And the beauty of it is the generation side of it too, right? So it's more than just a repository. It can actually generate things for you. So that's awesome. I think Nam, you had one quick thing that maybe you want to say.
Yeah, it might be to answer, it might be a little long, but I was gonna ask, so what's the trade-off for using LangChain? Because it provides easeability, right? Are we sacrificing a lot of like the flexibility in terms of integration to the product?
Good question. In the next 30 seconds, you probably are sacrificing something. Any framework that you use that builds on top of existing systems that are there, you're not going to have the complete flexibility of doing everything you want to do, right? And so there are some limitations obviously built into it. I think the power outweighs any sort of things that you would run into, because I didn't even talk about today about the asynchronous nature that is sort of built on top of this stuff. It handles a lot of error correction. There's a lot of great things, but yes, in any system that you build on top of, you're sort of at the beholden of the implementers, right? So you're definitely going to lose out than if you just wanted to hand code this all yourself, for sure. So
Got it. Thank you.
yeah, well, cool. Thank you, everyone. I appreciate this. I'm going to, we'll post this out on our YouTube channel. If you go to videos or video.appliedai.mn, please subscribe there. I'll also post a link out on the meetup as well. And expect us to do this again in a couple of weeks. Actually, I've got a couple of ideas. Looks like we might do some text image generation, and we'll probably focus a little bit on local models, local language models. And I also want to introduce the concept of history, right? How can you actually have these models continue, allow you to have follow-up questions for it and have it sort of understand the contextual aspect of it. So thanks, everyone. Have a good day. I appreciate it.
Thank you.